Okay, so in this video we'll be doing a little experiment with Python and Rust. So we'll be using both of these languages to compute the value of pi. So let's get started with Python. I'm gonna create a directory called Python, and in that I'll create a script called calculate pi.py. Alright, and now we can navigate inside Python. Okay, so first of all, it is an iterative process. So we are going to use a for loop to determine the value of pi. So for that, we have to first pick a really large number. So to start with, let's choose 100 million. Okay, so next we define a function that actually calculates pi. So this is just a function that I read somewhere, and so let's just use that. So I'm going to call it calculate pi, and as an argument it takes number of terms, which is an integer, and it returns a floating point number, which is the value of pi. So we're going to define a couple of variables here. So first of all, we have a numerator. So its value is going to be 4.0. And then we have a denominator whose value is 1.0. And then we have operation whose value is also 1.0 at the start, and then we have our pi variable. So we're going to initially call it 0.0, and then we have a for loop. So we're going to say for underscore in range n terms, and then we're just going to use this iterative process to compute the value of pi. So it's operation multiplied by numerator over denominator, and then we reassign denominator to be, so we add 2.0 to it, and then we reassign operation, and we store it as a multiplication of operation multiplied by minus 1.0. Right, and then we just return pi. So let's actually decrease that number so we are able to see it running. So I'm just going to create an if block here. So we're going to say pi equals calculate pi, and then we're going to pass n here, and then we're just going to print pi. Okay, so let's try to run this script. So Python calculate pi. So as you can see, it's working quite well. We have 3.14159 and so on. So I'm gonna write some stuff to actually measure how long it takes to compute pi. So for that, we're gonna have to import the time package. So we can say from time import time, and then we can store the start time here, and then we can copy it down here and call it end. And so let me just copy these print statements. So we can paste this here, and there we go. So let's try running it again. So nice, we have the value of pi, and it took 4.6 seconds for Python to compute this value. Great. So now let's do the same thing in Rust. So I'm going to create, I can actually use cargo to start a new crate. So I'll say cargo new so I'll just call it Rust for now. Okay, so we have this directory. Now let me just cd into it, and let's just run and see if hello world is working. So there we go, hello world is working. Great. So now all we have to do is just replicate whatever we wrote here and write it in Rust. So let's create a constant first at the top. So it's going to be of a U64, and we can call it 10 million maybe. It's a good start. Okay, so now we have, let me just define the main function here so we can get rid of these warnings. Okay, so now let's define the actual calculate pi function. So we can call it the same name as we called in Python, so calculate pi, and it takes n terms, which is of type U64, and it returns a F64. Right, so let's define the other variables. So we have our numerator, so it's going to be 4.0, and then we have denominator whose value is 1.0, and then we have operation whose value is also 1.0, and then we have pi, so pi is equal to 0.0. Now as we saw in Python, the values of these three variables are going to change, so I'm gonna define them as mutable variables. So I can just say mute here, and now these variables are mutable and their values can be changed. So now let's write the for loop. So for underscore in 0 to n terms, and then we're gonna update the pi as follows. So operation multiplied by numerator divided by denominator, and then we're gonna update the denominator as follows. So it's 2.0, and then operation is equal to operation multiplied by minus 1.0. Great. So once that's done, we can just return pi here. Great. So now let's call this function in the main function. So let me create a pi variable and store its value. So calculate pi, and we can just call it in. And now let's just print the value here. So we can say pi, and great. So cargo and run. So yeah, we're getting the value of pi. Now we want to measure how long it took for Rust to compute this value of pi. So for that, we can use the instant. We can use a standard time crate from the standard library, and there is an instance struct that we can use. So let's import that first. So it's standard time and instant. So then we can just say let's start equals instant now, and then let duration equals start dot elapsed. So this will give us how much time has elapsed since this statement. So then let me copy the format statements. Okay, so they're going to go here. So we're just printing the value of pi that we're computing here, and then we're just printing duration here. Great. So let's run this program and see if it's working. All right, so it takes Rust about 0.21 seconds to compute the value of pi by using 10 million iterations, right? So now we can clearly see the difference here. So let's just go back and run the Python program again. So Python calculate pi. So Python takes 1.25 seconds. Now, if I just increase it to 100 million, let's see how Python does now. Okay, so for 100 million iterations, it takes Python about 14 seconds to compute the value of pi. So let's do the same thing in Rust, and let's see how long this takes. Okay, so we go back to Rust directory, and let's just do cargo run dash release, because that's where Rust's compiler does some optimizations. So for that, 100 million iterations take Rust about 0.12 seconds, which is crazy fast than Python. So maybe you're thinking that, is there a way we can speed our Python program here? And if you're thinking that, then you're in luck, because there's definitely a way. So the idea is to write the program in Rust and then compile it and then use that binary in our Python program. So I'm actually going to write some benchmarks. So let's do the Rust one first. So let's create a empty file called benchmarks. So we have Rust. Let me just write the number of iterations. So number of iterations is 100 million. So Rust takes 0.12 seconds. And we can do the same thing for Python. And let's compute that, how long it takes for Python to run this program. So let's go back to Python directory. And we'll do python calculate.py. Okay, there is an error here. Right, so we have to use PyO3. Okay, just hold on, it's gonna take a while. Right, so this time it took Python 9.33 seconds. I'm gonna replace that here. So now, now let's go back to the main directory and let's write a program that's written in Rust, but it's called from Python. And let's see how this one does. So for that, we are going to use a Rust crate called PyO3. So it lets us call Rust programs from Python. So I'm actually going to create a new package maybe. So we can do that using cargo new PyO3. Alright, so now let's go to PyO3 directory and let's see if everything is working. Actually, before I do that, I just realized I have to create this directory as a library, not as a regular crate. So I'm gonna remove this. So PyO3, and I can just give it a --lib flag, and it's gonna create this library for me. So let's go to the PyO3 folder, and we should see a lib.rs. Great. So now let's just get rid of this test from here. And so first of all, we have to add some dependencies here. So I'm just gonna copy these in. So if you want to test these, you can use it from this repository. Great, so we have to use this package from Rust, and so we save this, and let's actually bring this back for a moment, and let's run cargo build so that it gets all the packages and builds the dependencies. So let's just give it a minute. Alright, so it's finished, and let's see. So yeah, so let's start writing our function. So first of all, we have to import the prelude of PyO3 module. So we use PyO3 prelude and star. So this will import everything. And so now we want to create a Python function that's written in Rust, but it can be called from Python. So PyO3 provides us with some goodies that we can use for that purpose. So we're going to write py function, and then we're going to define the actual function that we are going to call from Python. So let's call that calculate. So it is going to accept an argument which is going to be called n terms, and then we can call it as view size type, and then it's going to return a PyResult type, which is also from PyO3 crate, so which is going to have our f64 based result, and then we're going to write our function down here. So it's actually not going to be very different, so I'm just going to copy from the Rust implementation. It's actually exactly the same, so let's copy it here, except that we have to, because it's a result type, so we have to write OK here, and then we have to pass by inside. Great. So now that we have our function defined, we also need a Python module that we can import into our Python file. So we can define that by using this PyModule statement. So PyModule, and then we're going to define the module here. So I'm going to call it calculate underscore py, and there are some arguments that we have to give it, so it doesn't really matter, you can write them as it is. And this one is also going to return a PyResult, and it's gonna be an empty tuple here. And then we can come into the function's body. So this is the module here, so we're gonna add our function. So we're gonna write module.add function, and then we can get the name of our function here. Actually, we're gonna use wrap by function first, and then inside, so it's actually a macro, so inside we're gonna give it the name of our function, the Rust function here, and then m here, and then we can just put 2 question marks here and end this statement with a semicolon, and then we can just return OK, and like that. Alright, so there's a typo here, I'm gonna fix that. Great, so no errors and everything seems to be working. Alright, so now I'm going to do a cargo build and dash release so that our optimizations are also applied. So let's just give it a minute. Alright, so it's finished building, and so the binary is found inside this target. Actually, let me collapse that first. So you go inside this PyO3 folder, and then inside a target, and then release, and there you will find this .so file. So we're going to have to drag that to the top level folder here. Great. So we have it here. And now let me create another Python file here, and I'll call it I'll just call it program.py. So now this binary, actually we have to rename this first. So we have to remove this lib part from the start, and there we go. So now this program file and this calculate.py.so file, these are in the same directory. So we can import it into Python. So we can say from calculate.py import calculate. So, and then let's try printing the calculate function. Let's see if it works. So Python 3 and program. So you can see we have a built-in function called calculate. Don't worry about this warning, it's appearing due to some reason. Alright, so obviously we can pass in a big number here, so let me just copy what we have in Python. So we have it as 10 million, and we can paste it here, and then we can pass in here. And then let me just also copy the print statements. So I'm actually going to copy this whole block. So we can do that, and let's just import time as well. Great. So now let's try running it. So Python 3 and program, and there we go. So now this calculate function is actually written in Rust, and then we compiled it, and then we are importing it in Python and running it, and you can see the difference that it makes in speeding things up. So let's just fill this, and you can see it's exact same number as it was in Rust. So it's significant improvement over a function written in Python. So I'm just going to call it PyO3, and it is also 0.12 seconds. So there you go. You can see that it is possible to write functions in Rust and call them from Python to increase the speed significantly.